of inertia of a rectangle, is it not? Formula Ixx was what? Bd cube by 12, Iyy was what? B cube d by 12. But let me take up a simple case with dimensions. I am taking up a rectangle of breadth 300 mm and depth 500 mm. Now I want values of Ixx and Iyy. What do you mean by Ixx? What? About horizontal and vertical centroidal axis. Horizontal centroidal axis means already you know moment of inertia of about any area about horizontal centroidal axis we call it as Ixx. Moment of inertia of any plane area about a vertical centroidal axis we call it as Iyy. So what is Ixx and Iyy? These are nothing but about the horizontal vertical central axis. That means first of all it is most important to locate the centroid. You know where does the centroid of a rectangle lie? It lies midway between the breadth, midway between the breadth and midway between the depth. So that these are your x-axis and y-axis. So for a rectangle already there is nothing new. We have derived standard formula. Directly you can use it. BD cube by 12. Iyy B cube D by 12. Which is the breadth? This 300 mm is the breadth. And this 500 mm is the depth. So that if you substitute, you will get 300 into 500 cube by 12. And using your calculator, if you simplify, you will get this value. And please note that we already had discussed this. The units for moment of inertia will be dimension to the power of 4. What are the dimensions of the rectangle measured in terms of mm? And it will be mm to the power of 4. If it is cm, centimeter to the power of 4. If it is meters, meter to the power of 4. But here, both the dimensions should be in the same units and it is given as mm. And here Iyy will be equal to what? B cube D by 12. Breadth is 300 mm. So you can't get the same answer. Okay. So as we see here, we get higher value for Ix. Higher value for Ix because the depth is more all about the vertical axis. More depth is more, that is why we get Ix as more. But for the same cross section, what am I doing? I am orientation has been changed. It has been rotated through 90 degrees. So is it not? The orientation has changed, or the breadth has become 300, depth has become 300, breadth has become 500. Will we still get the same values for Ixx and Iyy? No, because these are the same, but now you have to take this B as 500 mm and D as 300 mm. So if you now use the same formula, Ixx will be equal to what? B cube D by 12. Is it not? BD cube by 12. So that you will get Iyy will be what? 500 cube into. So if you see here, the orientation was kept with more depth, so that is why Ixx was more. In this case, the depth is less, so this I am getting lesser value. So moment of inertia will change according to the orientation also. So or if I keep the scale like this, so now you take up this example. You take up a scale in your hand. If you keep this orientation, you can bend it easily because about x-axis where the bending is happening, I am getting least moment of inertia. Whereas if I keep it like this, the orientation of scale, you can't bend it that easily because Ixx is more. Or in the simple case itself, if you see the beam in this position is 3 times stronger than the beam kept in this orientation. That is why in structures and all, if you say or Iyy, get it like this. That means if you take up a beam or you take any beam in your home also or anywhere you see, the orientation is so placed such that we keep more depth about which bending is happening. The breadth is minimal. Breadth is minimal, but depth is more. That is why we use beams in this orientation rather than this orientation. If you use a beam in this orientation, it is weaker. It will bend very easily. That you can try it with a scale also, plastic scale also, which I showed you in the previous class. So that is why moment of inertia also plays a very important role in structural elements. So you are seeing a rectangle, a beam of rectangular cross section. But in some cases, we will even have, I'll come to this later on, already the same thing. You will also have to calculate the moment of inertia of a T section, which is nothing but a composite area, about horizontal and vertical centroidal axis. For this, what we will have to do is, we have to have the concept of parallel axis theorem. We will be using very much this in our discussion now. So please go through this parallel axis theorem. So what is that? The moment of inertia of a plane area about an axis in the plane of the area is equal to the sum of the moment of inertia of the plane area about a parallel centroidal axis and the product of the area and the square of the distance. So I'll come to this once again. So if I want it about axis AB, I can calculate the moment of inertia about the axis GG. To that I have to add the product of the area and the square. So this is the parallel axis theorem you should remember, isn't it? IAB is equal to IGG plus AYC square. So this is the concept of parallel axis theorem, which will be used to calculate the moment of inertia of a T section or a composite area. What I should do is, now let me see the statement. What is my statement? Calculate the moment of inertia of the T section about a horizontal and vertical centroidal axis. So horizontal and vertical centroidal axis, that means it is first and foremost important to what? To locate the centroid of the composite area, which is nothing but a T section. You had done it earlier, but still I'll repeat that for your case. Before that, if you observe the given figure, it has an axis of symmetry, yes or no, vertical axis of symmetry is there. When a given figure has an axis of symmetry, G will lie on that axis of symmetry. Isn't it? So slightly towards the portion where there is more area. So locating G means you have to calculate what? X bar and Y bar of the reference axis. The reference axis I have taken the x axis here, but okay, the X bar is equal to what? 100 mm and Y bar is equal to what? Question mark, because I can't predict Y bar value. I have to calculate by our regular principle. What I should do? I should divide the given figure into two elemental areas. One horizontal dividing line, you have two elemental areas A1, A2. Then I should also mark their centroids G1 and G2. And now X bar is already known directly because of symmetry, but I have to calculate only Y bar. So I have to also get distances Y1 and Y2. So you are now in a position to tell all these. A1 is what? 200 into 50. Area of the rectangle is A1 is nothing but 200 into 50. A2 is 50 into 150. Now Y1 within this rectangle, this will be what? 50 by 2. To that you should add this distance, which is nothing but 200 minus 50, it is 150. All this was earlier the situation. Now calculating X bar, Y bar is not a big issue. X bar is nothing but directly 100 mm because of symmetry. This axis is cutting the given breadth into two portions. Same figure. Now, what was our interest? Our interest was to calculate Ixx and Iyy of the composite area about this axis. First, let me do it about xx axis. That means I will try to calculate Ixx only first. All these are the new things, same things, x bar, y bar. Now, let what Ixx represent the moment of inertia of the T section or composite area about the horizontal centroidal axis. Horizontal central axis. But this composite area, if you take, I can't calculate directly because I don't have any standard formula for the T section. I don't have any standard formula. So what to do is, I will do one thing. I will write this Ixx as equal to Ix1 plus Ix2. What is nothing? What is Ix1? Ix1 represents the moment of inertia of the area A1. The moment of inertia of the area A1, which you see here, which is nothing but this rectangle about this axis. So the area is lying here, but the axis is here. So to calculate the moment of inertia of this rectangle about this axis, I can apply what theorem? I can apply parallel axis theorem. That means I should be able to tell the distance between this the point G1 and this axis passing through G, or the axis XX. If I get this distance, I can calculate the moment of inertia by applying pi. Similarly, for the second area also, I will write as Ix2, which is moment of inertia of the area A2 about the horizontal central axis. So the central axis of the passing of the entire area passing through G is XX axis. But the center of the area A2 is G2. So if you see here, if I want to calculate the moment of inertia of this rectangle, I should once again apply axis parallel axis theorem. So that I will write Ixx as like this. Ix1 will be equal to Igx1 plus A1 YC1 square. So go through this is nothing but the equation derived from parallel axis theorem. What is Igx1? Igx1 is nothing but moment of inertia of rectangle A1 about its own horizontal central axis. Igx1. Moment of inertia of this rectangle about its own horizontal central axis, which is nothing but what BD cube by 12. Igx1 is nothing but what BD cube by 12. And A1 is what? Area A1, which I already calculated. What is YC1 means? Distance of the center G1 from this capital G or from the XX axis. Is it possible to calculate YC1? Yes, it is possible, because if you see here, I'll come to this. You already know Y1, Y1 was there. What is YC1 now? This is the distance. You have this is Y1 and this is Y bar also you have calculated. So YC1 will be nothing but Y1 minus Y bar. Now Ix2 also in the similar lines is nothing but based on parallel axis theorem, moment of inertia of a rectangle about an axis in the same plane is equal to the moment of inertia about a parallel centroidal axis. That means passing through the centroid G2, Igx2, which is once again BD cube by 12. But for this, it has to be taken as 50 mm and the depth has to be taken as 150 mm. And A2 already is there, and distance of centroid G2 from capital G is nothing but YC2. And what is YC2? If you see here, Y2 already we have calculated during calculating Y bar. So Y2 is nothing but YC2 is nothing but Y bar minus Y2, or still I'll write YC2 also as what? Y2 minus Y bar, because negative term, though if you see here, this y2 is lesser, y bar is greater, but if you subtract y2 from y bar, or is it not, it get negative sign, but a negative term on squaring will become still what? Positive. So that for yc1 I will write y1 minus y bar, and for yc2 square I'll write as y2 minus y bar. So you can figure out this, because already y1 we have calculated, y2 we have calculated, y bar also we have calculated. So let us take over igx1. What is igx1? And yc1 and yc2 have been replaced. What is moment? What is igx1? Igx1, it is moment of inertia of a rectangle about its horizontal central axis, which is nothing but BD cube by 12. What is the breadth of this rectangle? 200 mm, and depth is 550 mm. So that this will be Igx1 is nothing but moment of inertia of the rectangle about its own horizontal central axis, BD cube by 12, plus A1. A1 is already this 200 into 50. Y C1 is nothing but y1 minus y bar. Y bar we are already calculated. Y1 also there. Similarly, Igx2 will be moment of inertia of this rectangle about its own horizontal central axis, which will be once again BD cube by 12. But the breadth is 50 mm, depth is 150 mm. Is it not? And A2, you know, it will be 50 into 150, and the distance between the two axes, that is, or distance between G2 and G will be YC2, which is nothing but Y2 minus Y bar whole square. Now all have been tabulated. So this is the concept of parallel axis theorem for calculating moment of inertia about about composite areas about any central axis. So if you use a calculator, I'm sure you will get this answer for Ixx. And please note that it is based on the dimensions of the cross section, which are given in terms of mm raised to the power of 4. Similarly, I should calculate the moment of inertia of this composite area or T section about the YY axis. But now you please observe, G1, capital G, G2, they all lie on the same y-axis because that is a property of axis of symmetry, is it not? Now x bar is 100 mm directly we are seeing. But now in the same lines I will write the equation for Iyy. Iyy will be equal to what? Iy1 plus Iy2. So where Iy1 represents what? Moment of inertia of the rectangle A1 about the yy axis. And Iy2 represents moment of inertia area A2 is in the same another rectangle about the same y-axis. So Iy1 I will write as Igy1 plus A1 xc1 square. So that could just goes like a mathematical equation. And what does Iy2 go as? Igy2 plus A2 xc2 square. So now what is the meaning of Igy1? It is moment of inertia of rectangle A1 about its vertical centroidal axis, which will be equal to plus A1 into xc1. If you go by xc1 is nothing but on the same line x1 minus x bar. xc1 square is equal to what? x1 minus x bar whole square. Similarly, here for calculating Igy2, I need xc2. xc2 is not what? x2 minus x bar, or xc2 square is nothing but x2 minus x bar whole square, is it not? But if you observe this equation, don't you see this G1 is at the same distance from the reference axis here, and capital G is also at the same distance from the reference axis here, 100. So you see x1, x2, x bar, they are all equal here. So what will happen? xc1 will be equal to 0. xc2 also will be equal to 0. So if you come to this equation, xc1 is 0, xc2 is 0. So the product of these two becomes 0. So the final equation for Iyy will be just left out with that Igy1 plus Igy2. What is Igy1? It is moment of inertia of rectangle A1 about its vertical centroidal axis. The formula which you know, it is b cube d by 12. Breadth is 200, depth is 50. And similarly for this rectangle about its vertical central axis, b cube d by 12. B is 50, depth is 150. Now calculator, you can get the value. But now if you observe, we have not got the same values for Ixx and Iyy. They are different. So we should be ready to calculate the moment of inertia of such composite areas using parallel axis theorem. This is very much important. Likewise, we could have done it for even other areas like T section, I section, negative areas and all. But since you are not writing the conventional VT exams, I would only appreciate if you understand this concept, because the next semester when we regroup, we will start up with concepts of moment of inertia like this. So I have done it for a T section. You should only be ready to do it for our I section. This will be very much important. But still, okay, on that day, if you have forgotten, I'll be there to still revise. But for module 4, I would highly appreciate if you go through all the notes which I have sent and prepare yourself for the test 2. But the module 5 kinematics portion will be continued by my colleague, because in this week we have the NBA National Board of Accreditation visit to the college. So as a HOD, I have some more responsibilities. But for you, you have to take the test also from Monday. So in 3 or 4 classes, my colleague will schedule the classes and complete the concepts of moment of inertia, which will help you to take up MCQ based questions. But you will send the notes also, which are related to kinematics portion. So if you want, you can go through them also if you are interested. Anyhow, you are not going to write second semester exams of VTU, because they are being waived off for you. But credits will be based on first semester performance and second semester IM also, which you are going to score. So please also all the keenness in preparing for test 3 and any other improvement test given in future also. So thank you for the patient hearing. I will end up my class here for the day. Thank you.